Alright, we are back with another Algebra 1 state test review video. Today we're talking about standard N.Q.1 and standard N.Q.2 and standard N.Q.3. We're doing a threefer in one episode, so let's jump right in. Francine creates a bar graph showing the distance between her city and each state capital city in the United States. What unit of measure would be an appropriate unit for Francine to use to label her graph? These questions are more about logic, okay? So, if let's say you have a map of the United States, I'm not going to try to draw a map of the United States because it would be a terrible, alright, fine, I'll try to draw it. Gorgeous, okay. Someone screenshot that and send it to Miss Spittler. Okay, so we're over here. Like, we have Michigan, we have Ohio here, right? If you were to try to create a bar graph showing how far your city is, how far Toledo is from each capital city in the United States, you would be looking at having to go here, 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 and here. Is centimeters an appropriate thing for this graph? No. Is inches an appropriate thing for this graph? No. Meters? No. Miles. If you think about it, even from up here to down here is like 1,500 miles. This looks awful. I hate it. Alright. This is like 3,000 or 4,000 miles, I don't remember. Let's move on. Question 2. From the Spring 2021 OST. Raphael drove 4 miles at an average speed of 40 miles per hour. Which unit is most appropriate to determine the amount of time Raphael drove? So, you drove 40 miles an hour, right? That means that you drove 40 miles in 60 minutes. Okay? Now, if you drove 4 miles, what would you have to multiply 4 by to get to 40? Or what would you have to divide 40 by to get to 4? 10, right? So if you drove 4 miles, that would mean you did it in 6 minutes. Is it appropriate to say that you drove 4 miles in 6 miles per hour? No, because we're describing time. And since we're describing time, it's not going to be miles either. So we come down to minutes or hours. Okay? If you drove 4 miles in 6 minutes, would you tell someone, I drove it in 6 minutes? Or would you say, I drove it in 0.1 hours? Typically, if you're going less than 1 hour, you would say the number of minutes. I mean, maybe if you were like 55 minutes, you'd be like, it was just about an hour. But this isn't close to an hour. You would just say a few minutes. Okay. Question 3. Shelley measures the dimensions of her bedroom so she can buy new carpet. Which set of dimensions for Shelley's carpet is most reasonable? Okay. So let's think about what this would be. Okay. 12 feet by 10 feet. 60 inches by 36 inches. 20 meters by 18 meters. And 100 centimeters by 80 centimeters. Give me 1 second. I'm going to go pull up the Algebra 1 reference sheet because I want to see what they give you, if anything, for this question. Alright, so I went and I pulled it up. So they tell you that 1 inch is about 2.54 centimeters, 1 mile, 1 yard, 3 feet, 1 foot, 12 inches. Alright, so that gives you a little bit of information, but not overly much. Enough to know that 12 inches are in a foot. So if you did 60 divided by 12, 36 divided by 12, right, that would be 5 feet by 3 feet. Could you live in a bedroom that is 5 feet by 3 feet? No. Okay, 20 meters by 18 meters. Okay, let's think about what this means. Okay, there are 100 centimeters in 1 meter. That would mean that this is 2,000 centimeters by 1,800 centimeters. Okay? Which, when you think about how small centimeters are, that doesn't sound like a lot. But let's consider, if you think about a standard ruler, right? You think about a standard ruler. You have, the ruler has the inches side, it has a centimeter side. And for every 12 inches, which is, as we just established, the same as 1 foot, there are 30 centimeters on a ruler. Okay? So if you divide 1,800 by 30, let's even put it in Desmos so we can be sure. If you divide 1,800 by 30, you would get 60. If you divided 2,000 by 30, you would get 66.667. Yeah, 67. Is it conceivable to have an average bedroom be 66 feet by 60 feet? I would say no. If you even consider our classroom, I want to say, if I had to take a best guess, is probably about 20 feet by 15 feet. So that would be almost 3 times as big as our classroom. 100 centimeters by 80 centimeters. Well, we just talked about the conversion of centimeters to inches. So 100 centimeters would be, 3.33. 80 centimeters would be even less, 2.66. That's not conceivable for a bedroom. So 12 feet by 10 feet seems to make the most sense. And when you think about how big, excuse me, sometimes you have to think about estimations in weird ways if you're having trouble visualizing it. So think about a standard bedroom, right? Think about your bedroom. How many times could you lay on the floor, end to end, if you stuck your foot at the top of your head, how many times could you lay on the floor and go from one corner of the room to the other? And then repeat that process. The most realistic would be 12 feet by 10 feet. All right. A formula for acceleration, A, is A equals V over T, where V equals D over T. The variables are defined as follows. V for velocity, D for distance, T for time. Select all of the expressions that could represent a unit of acceleration. So first, let's break this down. V, okay? V equals distance over time. And A is equal to distance, this is going to be small writing, but over time, that's your V, all over time again, otherwise known as A equals distance over time squared. Because if you were to do this division, you would put time over 1, and you would get distance over time. You would do the keep, you would do the change, you would do the flip, and you would end up with time squared. Okay? So, we're looking for anything that could be a unit of acceleration. So anything that is distance over time squared. Nope. Foot second, good. Mile, hour, not squared. Kilometer squared, hour, nope, squared's in the wrong spot. Meters per second squared, yup. Meters squared per second squared, no, because you can't have meters squared here. Select all, as we talked about many times at this point, more than one right answer. We checked 2 of them. That's that. Question 5. Select the most appropriate unit for each situation. We have feet per minute, square feet per minute, cubic feet per minute. So here's how I remember this, okay? When you talk about exponents, if you don't have an exponent, it would just be 1, right? You don't list it. If you have an exponent of 2, we refer to that as x squared. So we go with square feet. If you have an exponent of 3, that's x cubed, or cubic feet, okay? Feet per minute works in a line. Square feet per minute works in an area. Cubic feet per minute works in volume. You're thinking of one dimension, either going left or right, or up or down. 2 dimensions, where you're thinking of filling in some sort of box. Or 3 dimensions, where you're thinking of filling a 3-dimensional shape. Imagine, say, for drawing that off the cuff. That's amazing. So, the rate of walking to school, right? That's usually a straight line. Or, at least, it's a little bit of a curve, but you're not filling in anything, right? So that would be feet per minute. You're thinking only in one dimension. I'm walking forward, I'm turning right, I'm walking to the right. The rate of painting a bedroom wall, okay? This we're working with 2 dimensions at once. You have to fill in the entire box of the wall. That would be square feet per minute. The rate of filling a bucket with water. So when you think of a bucket, usually you'll think of like something like this. That's 3-dimensional. That's a bucket. A bucket is 3-dimensional. It has an X, a Y, and a Z. That's cubic feet. The rate of mopping the kitchen floor. Think about what your floor looks like. Your floor just looks like a rectangle. You're just covering water, covering the entire floor with water. That would be square feet. If you think in one dimension, if you think in one direction at once, you are going feet per minute. If you're thinking 2 dimensions at once, like filling in a box, you're going square feet. If you're thinking of 3 dimensions at once, filling something, you're going with cubic feet. Question 6. Michelle holds a small rock in her hand. Density can be found using the formula D equals mass over volume. Which unit would be the most appropriate for calculating the density of the rock? Okay, think about what mass is. Mass is weight, okay? So you're looking for like a pound, an ounce, a gram, kilogram, depending on where you're at, whether you're using the imperial system or the metric system. Volume is something cubed, okay? So, volume is something cubed. So in this case, we do have a whole bunch of things that have a mass and a volume cubed. So now we have to think about what's most appropriate. Okay? She's picking up a small rock. Think about a small rock. Think about if you go outside, right, and you just kind of dig around the dirt for a minute, and you pick up a small rock that can fit in the palm of your hand. Okay? Which unit would be the most appropriate for calculating the density of that rock? How are you going to consider how big that rock is? Pounds? Yeah, that's appropriate. But millimeters? Think about how small a millimeter is. Okay? We go back to the ruler, right? We said that 30 centimeters is equivalent to 12 inches, or 1 foot. Okay? Millimeters are 10 times smaller than centimeters. So this would actually be 300 millimeters in 1 foot, or 300 millimeters in 12 inches, or roughly using Desmos. Ooh, we've lost everything. Um, we've lost Desmos. Give me 1 second to fix this. We have retrieved Desmos. Or, in the case of this, 300 millimeters divided by 12 inches means that you have approximately 25 millimeters per inch. So would you use millimeters as your unit of volume? No. Grams and centimeters. We'll come back to this one. Kilograms over meters. Meters are big, okay? If you want to make a really rough estimate, and I mean a really rough estimate, 1 meter is a little under a yard. Okay? A yard is 3 feet. 3 feet is 90 centimeters. There are 100 centimeters in a meter. So 1 meter is a little bit under a yard. Do you think we conceivably use that? No, that's too big. Ton. A ton is 2,000 pounds. We wouldn't use that for a small rock. The most appropriate would be B, grams per centimeter. Grams is a reasonable amount of weight to represent a small rock. Centimeters is not too small but not too big that you could get away with using it. So you would use grams per centimeter. Question 7. Which rule will give the most accurate measurement for the length of a small object? I'm just going to dial this in that it's A. No matter what kind of object you're measuring here, accuracy is always more determined by how many partitions you can split this into. Because even if you have something that's 2 inches long, if it goes out to like here, what in the world how are you gonna call that? And that's the same problem that you have here. And it's less of a problem here, but you could still find a little bit of space. This one has the least amount of space where you can't accurately call anything, so this would be the most accurate. Question 8. Maureen collects rainwater in containers of the same size and shape for her garden. She wants to estimate how long it will take to fill one empty container. Select all the following options that Maureen needs to know to make this estimate. So, she wants to collect rainwater in containers of the same size and shape for her garden. She wants to know how long it will take to fill one empty container. So, if she's trying to figure out how long it takes to fill one empty container, she doesn't need to know the number of containers. Okay? She doesn't need to know the total area of the garden, because that has nothing to do with the amount of rainwater in the containers. She doesn't need to know the different types of plants in her garden, because again, that has nothing to do with collecting rainwater in containers. What she needs to know is how big is the container and how much rain you get in a day. That's all she needs to know. If you have a if you have a container that has a volume of 10 liters cubed and another container that has a volume of 20 liters cubed, obviously that's going to take longer for you to fill. If it's only raining an inch a day versus 3 inches a day, obviously that's going to change how fast the water fills. How many containers you have does not matter for the time to fill one container. If it said how long will it take to fill all the containers, then she needs to know how many containers she has. But we're only talking about filling one container. One single container. So all we care about, how big's the container, how much rain we get. I just knocked my camera to the side. That's how passionate I am about this question. Alright, so that's going to do it. Actually, no, we'll include this one in here too, as a freebie, because the standard is only one question. So, select all the expressions that are equivalent to 16 to the 5 halves. So, we'll go into Desmos. We're going to include N.RN.2 here. It's a freebie. We're going to put in 16 to the 5 over 2. And it tells you that that is 1,024. And all you're going to do is you're going to put in the other choices. and you're going to see if that equals 1,024. 4 to the 5. Whoops. Does that equal 1,024? Yes, you check it off. 8 to the 5? Well, 4 to the 5 did. 8 to the 5? Well, no, that gives a way bigger number, so that's a no. The square root of 16 to the 5. The square root of 16 to the 5. We're going to open up our keypad here. We're going to hit the square root button. Oh, goodness, that's not what I want. We're going to hit the square root button. We're going to hit 16 to the 5, and that gives you 1024. You check it off. This would be the fifth root of 16 squared. I can tell you now it's not going to be that, but just for fun, let's go take a look. Because 16 squared is not 1024, but remember, to get to custom roots, like the fifth root, you need to hit function, go all the way down to number theory. You can put in the fifth root of 16 squared. That gives you 3. So that's not it. So then we have 16 to the second times 16 to the 1/2. 16 to the second times 16 to the 1/2. That works. 1024. Check it. 16 to the 5 times 16 to the 1/2, and that gives you 4,194,304, which is not 1024. Whew. So that does it for these 4 standards. We knocked out 4 standards in one go. If you have any questions, feel free to ask me in class. I hope I can clear things up for you. Otherwise, good luck on your state test.